So the bottom line is that Linux is the foundational technology for cloud data centers. If you want to be successful in your cloud career, you have to know Linux and know it well. Hey, and welcome to the Get Into Cloud podcast. My name is Coyne. Today we're going to talk a little bit about Linux. And to tell the story of Linux, it really helps to start with a little bit of backstory to IT in general. And a long time ago in a galaxy far, far away, AT&T and IBM and very large companies developed very, very large and powerful computers that we call mainframes. If you've seen the movie Hidden Figures, you'll remember the scene when the computers they had to bust the top of the door to get these huge IBM computers into the data center to be able to process massive amounts of data. And those are what the computers were used for back then. Research, rocket science, those kind of applications, or the stock market, or data and analytics for a large company. A lot of what mainframes are still used for today, very large applications, very high transaction rate. And that is what computers were at that time. And it's not until Intel comes along and creates the x86 platform and we start having the kind of desktop PC revolution that we're introduced to the concept that a computer could be on your desk, or that there would be a computer in every home. So this is quite revolutionary at the time. And there was a gentleman by the name of Linus Torvalds who lived in Finland. He was computer science major, and this is in the 90s, the early 90s. And he's familiar with Unix. Unix is the operating system that most of the mainframes run on at the time. He's familiar with Unix. He's in the computer science program, but he has an x86 computer. And so he starts to think that he might try to create his own operating system that would port some of the concepts of Unix to the x86 platform so that he could write an operating system to interface with the computer he had. And so that's where he begins that process, the creation of a new operating system called Linux that would interface with the x86 platform. And he also utilized something at the time that was very new and very cutting edge, and that was open source software, the use of community developers to create this operating system. And that we accept open source today as not only being on par, certainly, with proprietary software, being better than proprietary software in many cases. But back then, there was a huge question as to who's writing the code that's going to go into your operating system. How risky is it to let strangers put code into your operating system or into your software? So it's a big leap forward. And as the boom of the x86 platform marched on, he rode that wave into ubiquity, right? Linux becomes the default server operating system for commercial and enterprise applications that's kind of sit beside the mainframes. So you can imagine a huge mainframe is running some sort of back-end system, your ERP system or something like that, and you might have these Linux servers running on x86 Dell servers in your data center that are running other applications or smaller applications and things like that. So that's a little bit of how Linux came to be. There's, of course, way more to the story. This is very abbreviated, and you can look up more of that online. But it was a revolution. It was a new operating system that certainly revolutionized the data center. And Linux is very near and dear to my heart because at the beginning of my career, I started out as an email administrator. So I was working on Lotus Notes and BlackBerry administration at the time, and very, very early in my career. And It was, which was great, but I was definitely low man on the totem pole, and there wasn't really anywhere to go from there. If you managed email for a small company, maybe you could go manage it for a large company, but there's not really a lot of upward mobility. I was always looking for additional projects and things to do to try to grow. And I got that opportunity because the company, which was quite large, a Fortune 500 company, didn't have any kind of spam filtering in front of their email. And they began to look for software to install and to solve this problem. It was all very expensive, and budgets were tight. So we started to have a conversation about installing an open source server with ClamAV and Spam Assassin on it. So this is quite popular back in the olden days, but you could take it, an open source server and put ClamAV, which was an open source antivirus software, and Spam Assassin, which was a spam filtering software that would grade your emails based on what it saw in the emails, and then shuffle some off into spam, and then try to filter the ones that it thought were spam and let the ones through that it didn't. And so I raised my hand to try to help to build that application server and to get that in place in front of our email servers. And I did a lot of research. There was a lot of configuration work and troubleshooting. Eventually, I was able to get it running. We were able to put it in production in front of the email server, and it worked effectively. And they kept it in place until they ended up migrating off of Lotus Notes and onto Microsoft Office. And so we had a lot of success there, but it was during that process where I reached out to the server team at the same company, and I told them about what I was doing, interfaced with them a little bit to get guidance around things that were allowed in the data center and those kinds of conversations. It was through those discussions and the success of getting that system running that I'd made connections with that team, and eventually they asked me to come over to the server team. So that was really the beginning of a serious IT career, away from, going from being an admin to being someone who was going to be an IT engineer, and eventually get into Linux and Red Hat, and then move into VMware and cloud. So the bottom line is that Linux is the foundational technology for cloud data centers. If you want to be successful in your cloud career, you have to know Linux and know it well. It's very important. So I'm going to start a little bit about the different flavors of Linux and talk through them, but I will caveat, I'll start at the beginning and say a lot of the things in IT, a lot of the flavors of Linux, the operating system names, people have different ways of pronouncing these things, and people might be upset when you pronounce it one way or the other. I just pronounce it the way that I'm familiar with and what I've heard other people pronounce it. And what you'll find is that different people pronounce it differently, and it's not really a big deal. So we'll talk a little bit about the different distributions of Linux, which I will call flavors. There are an unlimited number of Linux flavors out there. They can be customized, everything from the GUI to things that are installed, the types of kernels, the upstream distribution that they come from. There are a lot of different ways that these flavors of Linux are built, but I want to focus in on the ones that you will likely encounter when you're dealing with a cloud data center with AWS specifically. And the first one is Amazon Linux. Amazon Linux, Amazon Linux 2, Amazon Linux 2023. Those are the top three Linux distributions that you'll see in Amazon. And the main reason why is that they are a downstream similar operating system to Red Hat. So if enterprise users had used Red Hat before, then Amazon Linux will feel mostly familiar. And it is supported. It provides enterprise support if you've purchased support in AWS. So by purchasing a certain level of support in AWS, you get Amazon Linux operating system support as well. So that means if you have a problem on your Amazon Linux server, you can raise a ticket in the AWS console and get support for your operating system as well. And what you'll find is that operating systems that are supported in the enterprise are going to be the ones that are most popular, because an enterprise corporation can't be in a situation where an operating system isn't working and there's no one to call to support it, right? They need to be able to call someone who knows the operating system well enough to be able to fix it within an SLA, right? Within a period of time. So Amazon Linux 2, very popular, particularly in Amazon. And I don't know if I don't think it's an upstream clone of Red Hat. It is similar to Red Hat in many ways. It has diverged from Red Hat a little bit on a couple of different things that I'll talk about in a minute. I don't see a lot of Red Hat in AWS, but there is a little bit out there. Most of the time when I see Red Hat, it's because the company has on-prem Red Hat. They've already paid for support, and so then they run Red Hat in AWS as well, and they use their support licenses from on-prem and they apply them into AWS. And that is really one thing that corporations will do often the time is consolidate. If they have something that they do in one place, they want to do it everywhere. So if they already have Red Hat on-prem, they will often use Red Hat in AWS as well. The second big one is Ubuntu. Ubuntu is very ubiquitous. Generally speaking, it's one of the older Linux distributions, very popular, and because it's popular and it has a very big community, it's very easy to pick up. There's a lot of information and community support around utilizing Ubuntu, which means there's a lot of documentation, a lot of ease of use, just quite simple to use. And so that's why you see it everywhere. You can get enterprise support through Canonical with Ubuntu. And so really in the early days of IT, you really just saw 3 different OSs, and that was Red Hat, Ubuntu, and SUSE. But now SUSE Linux, I don't really see anywhere anymore, and see very little Red Hat. I do see a lot of Amazon Linux, a lot of Ubuntu. The next flavor that you will see a lot is Alpine Linux. Alpine Linux is a version of an operating system for containers. It's super light, runs in RAM. It's very fast, it's very small, and really just focused on containers. So if you're dealing with Docker, you're dealing with Kubernetes, you're working with containers at all, you'll likely run across Alpine Linux. But those are really the big ones. You'll see a smattering of other ones here and there. You might see some SUSE laying around. You might see some CentOS, which is a downstream clone of Red Hat without the licensing requirements and different repositories for upstream package management. But most of those are dying or going away. CentOS has been changed in a way now that most folks are moving to other versions and distributions of Linux. So that's the flavors. And next, I want to talk a little bit about the basics inside of the operating system itself, inside of Linux. Regardless of the flavor you're looking at, what are the kinds of things that you need to understand? And the first starting place would be the shell. When you log in to Linux, you're interacting with the shell. The shell is like on Windows, a command prompt, or a terminal on a Mac, where it is the interface that you're using for sending commands to the operating system. And the most common and the most ubiquitous shell is called Bash, Born Again Shell. And it is if you've heard of Bash scripts, those are scripts of commands that run on that shell. Other popular shells are the Z shell, and there's almost as many shells as there are versions of Linux. So there are a lot of them. Bash is the one that you need to understand the most. You need to understand how to run the commands that Bash expects for manipulating the operating system. And I'll talk about some of the things that you need to be able to do, but also being able to write Bash scripts that can script finding if a file exists, opening, reading from a file, writing to a file, running a process, killing a process. Bash scripts will be used to automate all kinds of activities on the server. So you need to understand the basic functionality of bash scripts, a little bit about if-then. You probably don't need to go deep into logic gates and programming around bash scripts, but you should understand generally how they're formatted, how you would write one yourself, and how you could utilize those, save them, and run them potentially on the operating system. The second thing that's important to understand is cron. Cron is a system that allows you to schedule activities to run, scripts to run, commands to run on a certain time frame. So cron is used pretty heavily in a server where you need some activity to happen once an hour, once a day, once a week. This was utilized a lot in the past to kick off backups on a certain day of the month, because you can actually say a certain day of the month, a certain time, do this activity. You can say do something so many days, or every Wednesday, or every other Wednesday. So there's a lot of flexibility in cron. It's effectively a scheduler to schedule when some activity will happen. You want to understand how cron works, how you could utilize cron to run some kind of script, or run a particular command or a script, understand how the number formatting and stars and things like that work. It's not terribly complicated, but you'll want to be a little bit familiar with how that works. The next is the operating system, the file system, understanding the Linux file system. You need to generally understand the root of the file system, how to navigate around the file system, where you might find certain files. If you're looking for logs, where would you go? And now it won't be the same for every flavor of Linux, but there are some generalities that you can begin to develop as you work with more and more Linux flavors and distributions. So if you're looking for logs in varlog, that's probably a great place to start. Etsy is a great place to look for configurations and installations, but generally understanding how to navigate around the file system, how to change directories, make directories, remove directories, search for files, check the size of files, right? It's not uncommon for an EC2 instance to run out of disk space. And it could be, you could extend the disk space, but that's going to increase the cost. So the first step might be to go onto the server and see if there are any big files that could be deleted, right? So that might be some activity that you have to do. Or it might be that your bash script runs, it logs some output to a file, then you need to go find the file and read what the output of that log was. Okay, so basic file system understanding there. Checking for services, checking services are running or stopped, understanding which services will start when the computer starts, and understanding when they will start in the init sequence. All of that can be very helpful. Most of all, checking if services are running top and seeing, who's using the most CPU, who's using RAM, what processes what is the parent process that kicked that off. So really understanding how processes and services are run. How could you start a service from the console if you needed to? How could you kill a service? How could you stop a service? If it doesn't stop, how could you kill it? And understanding how those services work. Also checking if a service is running, what port is it listening on? Like, is it listening on a port? What IP is it listening on? Is it listening on one of your attached IP addresses, or is it listening on all IPs? So having a good understanding of how you check services and manage services is going to be very important. Disk, CPU, and RAM basics and performance. I already talked about top. So this is kind of the same thing. How can you check whether the CPU is pegged or not? It's not the same as Windows. When you look at Windows, it'll tell you it's running at 98. When you check in Linux, it'll tell you it's running at 1.2. You have to understand what that means. Understand the management, how to check for I/O, could be a totally different command to look for IO than it is, than using top. It is a different command, right? Top's not going to show you disk IO. And so understanding all the commands you need to get basic server performance or disk performance or CPU performance, so you could troubleshoot an issue with an application. And then logging, you need to understand how logging works, logging to system out, logging to the error log, logging to var log, and to logging to files, how those logs are rotated and managed, really kind of understanding a lot of how the logging works on the system, because when you run into a problem, you should go to the logs first. Those logs are going to give you the best indication of what the problem is. You're going to be looking for error messages that are going to point you in the right direction. Now, the big one is installing applications. You need to understand if you stood up a brand new Amazon Linux server and you were intending to run a ClamAV Spam Assassin server, like I mentioned at the beginning, how would you install those applications? How would you find them? How do you figure out what the upstream repositories are available? How do you extend the available repositories to install things that are outside of the typical installation pattern for those servers? So you really are going to need to look at how to install applications, how to uninstall those applications, how to install different versions, how to install from not install from the internet, maybe install from an S3 bucket or another package. So you really want to key in on understanding installation and application installation. You have to do this all the time, particularly if you end up in doing cloud DevOps work. You'll do it a lot because your DevOps pipelines will run on Linux, and you'll need to do a bunch of installations to get you through your pipeline to get it deployed. If you're in the cloud operations side, you're going to be doing installations to prepare servers for their applications to run. So this is the main use, the main value you're going to get from Linux is to install and run an application on it. And so understanding how to do that is critically important. One big difference you'll need to know to install applications is to use different package managers. And this really kind of goes back to the understanding the different flavors of Linux that you'll see. And some of the most popular package managers is Yum. Amazon Linux uses Yum, CentOS uses Yum, and Red Hat 7 and before uses Yum as well. And the common Yum install HTTPD, that would install an Apache web server, or Yum install Nginx. So that's the one that I end up using the most. There's a newer version of Yum called DNF, Dandified Yum. It's on RHEL 8. It might be used by Amazon Linux 2023. I actually don't know, because there's a couple of big changes coming in Amazon 2023 because it's making the switch from supporting Python 2.7 to going Python 3 only. And that's one of the problems with the old version of Yum. So the next one is apt, or APT, which is the application package. Well, I don't remember what the T stands for, but apt is used by Debian, Ubuntu, Kali Linux. Those downstream versions of Linux use apt, and it's like apt get install Nginx, for example. And then for Alpine, which is the container version of Linux, or the Linux that focus very heavily on containers, they have APK, which is the Alpine Package Keeper, which is used to install packages as well. So that's a ton of information. I appreciate you guys sticking in with me to the end. There's a lot that I did not cover. Obviously, Linux goes super deep. I would really encourage you to look for training that's focused on understanding Linux very well. It doesn't hurt to pick a particular version of Linux and go deep on that, because you'll find that a lot of the information between the flavors, even though they're not totally similar, and they can have some very large differences, once you get comfortable and you feel comfortable in the Linux console and at the Linux terminal, you'll find that you're just a quick Google search away from making the connections. Very similar to once you learn Python, when you try to do Scala, it's really just at that point, you're just trying to translate. And so that's the pieces that you need to understand. The best way to learn more about Linux is to do Linux-based projects. You should try to do your own ClamAV spam assassin, whatever the new version of that is. Today, you'll want to get your own copy of Linux running, install an application, run a Valheim server, run this or that kind of solution. You'll get used to running into the common problems. You can do your research on Stack Overflow and on forums and things like that to find those solutions, and just feel familiar in the console, right? And that's where you want to be. That's where you're going to be the most successful. So thanks so much for listening. I hope you found this content helpful. If you did, please hit the follow button if you haven't already. And this was the 3rd episode that I put out. I wanted to wait a couple of episodes before I asked, but if you could just leave a comment with any kind of constructive criticism, comments. Do you like this format? Do you like what I'm doing? What's the parts you like the most? What do you hate the most? I want to read all of that and learn how I can make this more and more valuable for the folks that are trying to get into cloud. My goal here, I've helped individuals get into cloud one at a time, but that doesn't scale. And I wanted to create something that was free, easy to consume, that could get people on the right track and tell them what they need to know to be successful as they start their career. So I would love to hear from you. Please leave a comment or review, reach out to me on LinkedIn. Doesn't matter. I would love to hear from you and get any feedback, any and all feedback. I appreciate that. Until next time, bye.